In the next 75 minutes, we'll have the first workshop in this conference. The workshop will be run by two legendary figures who have greatly shaped the China Biographical Database project that Peter Ball has been leading. One of them is Professor Michael Fuller. Professor Fuller is a renowned scholar of Chinese poetry with a focus on the Song Dynasty at the University of California, Irvine. But like all legendary figures, Professor Fuller wears different hats at different times. Today, he's wearing the hat of the database architect of the China Biographical Database. The other legendary figure is Wang Hongsu. Since 2013, Hongsu has been the project manager of CBDB and is in charge of the development of CBDB online interfaces, data mining processes, and the communication with our collaborators around the world. Now, he's a senior project manager of the China Biographical Database and a research fellow at the Institute for Quantitative Social Science at Harvard University. Now, I'll give the time to Hongsu and Professor Fuller.
Yes, okay, this is designed as a beginning workshop. And so we decided to, that this is how we would in fact play it, that, from beginning, there we are. Okay, so we've been already had examples of networks, and people have referred a lot to CBDB, but we thought we would begin by, my function in all of this is basically to introduce some of the concepts, and then Wang Hongsu will take over and actually do the workshop part of the workshop. So I'm just introducing a few concepts, and as the writing in blue suggests, what I'm going to be primarily focusing on is the idea of a network and how situating networks within the historical context provided by relational databases help you dig a little bit deeper into networks. So let's get going. Okay. So we've already seen sort of the idea of letters has shown up a lot. And this is, it's a useful way to begin because it's a historical problem. It's a way of looking at historical problems. You want to know who was writing to who was talking to who, what people were in communication. And so letter writing is one good way to get into this. Now, and in particular, it's a good way to get into this because the CBDB has a lot of information on this, which is to say, we've got information about sort of that, say that person A wrote 5 letters to person B, B wrote 1 letter to C, C wrote 4 letters to D. D wrote a whole bunch of letters to A, and on and on and on and on. We have a whole lot of this sort of information. Okay, so how do you deal with this information? This initially starts out as simply a list. Who wrote to whom? But what you realize is that this thing that merely looks like a list, which is sort of a linear set of names and letters, in fact, has an implicit structure. And this implicit structure is a social network. Okay, so now a few terms. A network is a collection of nodes, the participants in the network, here, the letter writers and the recipients, who are connected by edges, which is, say, the relationships between the nodes. Okay, so, and so we have, for example, in the material I'll be looking at shortly, we have Yang Yi that wrote a letter to Jia Dao. And so Yang Yi and Jia Dao are 2 nodes, and the edge that connects the 2 of them is described by the fact of wrote letter to. Okay, so this is our standard company. We've got two nodes and an edge between them. And most networks deal only with this type of relationship, just two nodes and one edge. We don't complicate things. Now, let's say we have a lot of information about letter writing in the Sung Dynasty, and if you put it all together, you get something that looks kind of like this. This, as a visualization, isn't really all that useful. And there will be other ways to analyze large, complex networks that Wang Hongsu will introduce and that people will be talking about throughout these 3 days. However, for our purposes at the moment, let's simplify the story and take a look at just letters written in the early Northern Song. Okay, so this is our visualization of this network. Now, so the conceptual tools, and for that matter, the actual the software that lets you look at social network analysis tells you a lot about these networks that you can generate. And so Wang Hongsu later will deal in particular with descriptive ways of analyzing networks. Two central ideas, which are degree centrality. Degree centrality is basically the number of other nodes connected to any particular node. And so the question you can ask, okay, so who's got the highest degree centrality? And that's basically what node is connected to most other nodes. And then you've got a little bit more complicated situation that, again, Wang Hongsu will walk you through on betweenness centrality. And this is the idea of it's the number of times that a particular node serves as a bridge that is along the shortest path between two other nodes. So which is to say, this person is between all what other people in terms of setting up the relationships in the network. Okay, so these types of analyses are very important. And this is sort of the realm of social network analysis. But suppose we want to look a little bit deeper. In other words, we're concerned with historical data and trying to look at networks as historical phenomena. And so the question is, how do you explore the historical context that shape these letter writing practices? Now, a crucial one that is much debated in the transition from the Northern Song to the Southern Song is this idea of empire-wide or local networks. And so the question is, if you take a look at these letters, did they build or did they reflect empire-wide networks between people, or were these, or were they just local? And then another question is, well, okay, so you've got letter writing networks. Are these letter writing networks unique in terms of being either network-wide or local, or do they in fact reflect a lot sort of similar patterns to those you see in a lot of other networks defined along other criteria? So we can throw this in, and if you take a look, what this map is showing is you have all the various different letter writers are these dots here. The color of the dot shows, okay, so this person, the average distance for, it says he wrote to various people. How far away was the Jiguan of the people to whom this person was writing? And what you can see is that the people who were writing in Sichuan were writing on average to people rather far away. Okay, well, this is useful. But you can take a look that actually there are a lot of other red and yellow dots throughout the empire, throughout this map here. So this is early in the dynasty. Now, if you take a look at the kinship networks at the same time, you can see that there aren't that many dots that are red or yellow. And so it looks like kinship is still largely, we compare this, kinship is largely local, but the letter writing actually looks like it's much more long distance. And this is interesting. So if we want to look at the networks as historical phenomena, we need basically information about the participants in these networks to see how these might have an impact on the formation of these networks. And this is where relational databases come in. So let's take a look. So here's information that we have on one of the participants in the letter writing networks, Yang Yi. And so we know, we don't have a whole lot of place information from him. We know that his basic registry is in Puchang. We actually have a good deal of kinship information on him. So we have his grandfather, granduncle, et cetera, et cetera, et cetera. We have a whole lot of information about his social network. We, in fact, have 110 associations sort of for him. And we also have information on offices. He was an important official he held, and we have information on the posts that he held. Now, okay, so we have a lot of this information. How do we organize it? We could put it all into an Excel spreadsheet. So for each row in the spreadsheet, you've got a person. And each of the cells in this spreadsheet has all the information we know on a particular category of information. So place names, that's not too bad. Kinship, getting a bit crowded. Associations, this is a cell that is officially out of control. This thing is, you've got so much information in there that it's largely useless. Okay, in terms of actually being able to get access to it, to use it analytically. And so what CBDB does is it takes each of these columns, associations, office, kinship, et cetera, and turns it into a separate table. And all of the tables are, of course, well, in every record, in every one of these tables, so for that deals with Yang Yi, we start with Yang Yi. Okay, so for example, so this is reorganizing the data for Yang Yi, and we've got we've got an essay. Each record has one fact, right? And so this is, and you can have as many records as you need. So associations, if we need 110 records to represent all of Yang Yi's social connections, we got it. We can control it. As many office postings as we need, they're all there. So you can see. Now, but what begins to happen here is we're beginning to sort of restructure and rethink the very nature of the data that we're looking at. So, for example, as I say here, we've got people. Yeah, we got this. This is our what we're basically starting out looking at is people. But we're beginning to collect place names. As we list all the affiliations of all the people, we'll collect a whole bunch of place names. If we collect all the kinship relations of all the people, we'll begin to have a structure of all the kinship relationships that mattered in Song Dynasty China. Similarly, associations. We'll have associations are repeated over and over and over and over again, and begin to get a sense of what types of associations are crucial in Sung China. And then, of course, collect offices. So these things, places, office titles, social relationship, kinship terms, these become things. These become core categories in thinking through the social history of pre-modern China. When you do that, and you follow this logic, and you build a relational database, like China biographical database, we create what is called a relational database, which, as it suggests, is a database that is structured through relationships, connecting one thing to another. And we've got a grand total of 9 basic entities, 9 basic things that we're looking at. Places, institutions, social institutions, kinship, texts, people, of course, in the very center, systems of social relations, the modes of entry into government office, status categories, and then the office bureaucracy. So these are the things, the entities in which people participate. And then we record the ways in which people participated. There are many different text roles that people can have in relationship to text. They can be the author, they can be the publisher, they can edit, they can collate, they can do lots of things. And then, of course, kinship terms. We've got, anyway, all this should be pretty straightforward. So you've got these basic entities, relationships between people and these basic entities, okay? So what we have done here, as we've gone through all the texts of the Song, Yuan, Ming, in the Qing, and say, what are the institutions? What are the things that matter? How do we understand people's engagement with the social universe? And we build a database to collect this information. And what we've done is we've built a model of pre-modern China. So this is not merely a database, it is a model of the world of pre-modern China and a model of the interactions between people and that. Okay. So let's say we started by looking at people. But now what we have created in China Biographical Database is a world of interaction. And you can explore it in many ways. So for example, the maps that I showed earlier, and that's certainly the sorts of maps that Peter Bohl was generating in his talk, are looking at geographic distributions. I'm looking at geographic distributions of letter writers in particular, but you can all correlate geographic distribution with any sort of network that you care to generate. But we are looking here at sort of letter writing is a type of association, and we're looking at the basic affiliations of these people, and this produces a map. But there are many, many ways to look at interactions, and there are complex interactions. You can look at the social status of people from a particular region who were letter writers. It's an on and on and on. Anything you can think of, you can explore via CBDB. And this is where Wang Hongsu now takes over to begin to introduce you to ways in which you can look at historical network data through CBDB. Thank you.
Thanks for Professor Michael Fuller's introduction. Now it's my section. And in this section, it will be the practice social network analysis techniques in GetFi. And here we will practice the following techniques by using CBDB data. And many of these techniques have been mentioned in Professor Peter Bohl's keynote speech and in Professor Michael Fuller's slides. So let's see this. They are connected components, degree centrality, modularity, and betweenness centrality. Even if you are not familiar with this, you will completely familiar with them after our workshop. First, the tool which we will use to practice these techniques are GetFi. Or we can also call it Gephi. Here is a link of the quick start guide of GetFi. It's just a 32 pages menu, and it includes everything which I will introduce in the workshop. So we highly recommend you to read this quick start guide of GetFi. And in the email, we suggest everyone to download everything from this Google Drive about our workshop. And I assume you all download them. And we also suggest everyone to install GetFi. And if you have installed it, that's good. If you haven't installed it, you can just watch our workshop and practice GetFi later. Before we start to introduce GetFi, here is a very common error in Windows. If you install GetFi, it will say cannot find Java 1.8. And here we will have a 5 minutes introduction of how to solve this problem. And you can also find instructions here in these two Google Doc files. And in the install GetFi file, you can find a very brief instruction for how to solve this problem. And if you can't solve it, you can find some detailed information in the GetFi installation guide. And here we will briefly introduce the content of the GetFi installation guide for you to solve this common problem in Windows platform. And also don't panic, because we are recording this workshop. You can always, if you cannot follow any steps here in our workshop, you can always watch the video after the workshop. So let's see. If you open the link here, you will see the document. After you install GetFi, we suggest you to double-click your GetFi icon, this icon, to make sure that GetFi has been installed correctly. If it alerts an error message like this, then you can install Java. Here we offer the link of Java. You can download it for your own operating system and install it. For most of the users, it can fix that problem, but for some of the Windows users, it cannot fix this problem, and we will have some detailed suggestions for you to, or steps for you to solve this. So if you first install GetFi, second has installed Java 3, you still see this error. Now you can follow my steps. First, find GetFi icon on your desktop and right-click it. And open the location to find the location of GetFi. If you have this kind of problem, just follow me. If you don't have that problem, just have a rest. And then go to the upper level directory, which is GetFi dash with a version number. And then this directory, then go to the etc directory. Then find this getfi.conf, getfi.configuration. Then open it by any of your editor in your computer. If you don't know what kind of editor you want to use, just in search windows on your left bottom, type NOTEPAD, Notepad, So you can open it by a notepad. Just left click this icon, notepad. You will open your notepad and drag this getFile.configuration to your notepad. And I assume that on this line, it will be look like this on your own computer. You can find a line which begins with a pound sign and a space and a JDK home. This line. First, please delete the space and the pound sign. Then we finish almost everything to fix this problem. And then input your local Java directory here. And how to know your local Java directory? And here is my suggestion for you to find it. First, go to your PC. And then if you know you have installed Java in a disk, then you go to that disk. If you don't know, then go to disk C. And then go to Program Files. And in Program Files, you will find Java. You can find this folder. And then you can find JRE with a version number. Just go into this directory. Then copy this directory from your address bar. This is your Java directory. And then paste it here, file, then save this file. Now all set. I believe this can help you to solve the Java problem.
Now, I would just want to say, now we're at the end of the day today. So I would like to just say a few things about tomorrow and also about CBDB. Because many people asked the questions about the MBD data files that we can download that includes the CBDB data and the querying interfaces. That is a Microsoft Access data, so you can only use it on PC machines, or if you have a Mac machine, you have to run the virtual Windows operating system in order to use it. And of course, you also need to have Microsoft Access programs installed on your computer. Now, but CBDB is currently developing an online interface that will come out in the near future that will make the querying much easier. And we also have a SQL version, a SQLite version that you can also download from the official website of the China Biographical Database Project.
Now, we have fixed the Java problem for the Windows users. Then let's practice getFile for everyone. First, let's start from a very small and very simple network. This network, we can find 5 dots here. And in social network analysis, we call these kind of dots like nodes. So these, although they are dots, but we call it nodes in social network analysis. So if we have 5 nodes here, we will use this term in our workshop. And each node represents to one person. So here we have person A, person B, C, D, and E. We have 5 persons. And the line which are used to connect 2 nodes, this line, we call it edge, EDGE. So we will also use this term to describe this line. And this edge means person B and C has a social connection with each other. So A, B also had a social connection with each other. So here we can easily to understand this graph. We have 5 persons. These 3 has been connected with, these three can be connected with each other, and these two can be connected with each other. And it's very obvious for everyone to find that these 5 nodes can be divided to 2 groups, right? A, B, C can be connected with each other, and D, E can be connected with each other. We call that if the nodes can be connected with each other directly, like B and C, or indirectly, C cannot connect it to A, but he can connect to A through person B. So C to B, then he can connect to A. We call this kind of connected nodes as a connected component. So it's easy for us to read this as we have 5 nodes, we have 3 edges, we have 2 connected components, right? Okay, this is a social network analysis for an easy network. And then let's look into this data. And this graph was visualized by GetFi. And what kind of original data it is? So we will show the original data of this small network. If you have downloaded everything from the Google Drive, you can find a data folder. Just open this data folder. You can find here is sample.gdf. We will work on it later, but you don't need to follow my steps now. I will just show these things and open it by any of your editor. For example, I open it by Notepad. You can see these lines. And because the font size is too small, so I copied and pasted in the slides. It's the same data. The data can be divided to 2 parts by like 2 very long lines. And each of these long lines means that each of these long lines represent or it defined the data schema below it. So in this line, it defined the data schema of this part. And this long line defines the data schema of this part. So for the first part, it defines the schema of person name and their IDs. So for example, for this line, it's person A, we give it ID 1. Then person B, we give it ID 2. We use comma to divide data. So it's easy for us to read this area. We define persons by their IDs. Then the second section here, we define the relationship, or we define the relationships between these IDs. For example, 1 to friend means, how to read this? It's 1's friend is 2. So 1 is person A, 2 is person B. So we can read it as person A's friend is person B, right? Here you can you can read this as person B's friend is person C. Then person D's friend is person E. So here we defined the data, and here we define the persons, and we define the relationships. We can also read it as we define the nodes, and we also define the edges. So here we know 1 connected to A connected to A connected to B, B connected to C, D connected to E. Then let's go back to this graph. A connect to B, B connect to C, D connect to E. So it's a very easy schema for you to prepare some data. So in the future, if you want to visualize your data in GetFi, then you can just modify this file. this sample.gdf and like replace this person A, B, C, or add more lines by using your data. And you can define your data, the relationship by your data in the second part. So you can use it in future. Okay, let's go to the next step. Let's try to visualize this network in GetFi. Our target is here. We won't have the nodes. We won't have the edges. We won't have the color of the nodes. We also want to show the labels of the nodes. Let's do that step by step. First, open this network. So in this workshop, I will show everything on the slides. So you can follow my steps or follow the steps on the slides, and you can follow one step by step and operate or do it or practice it in your own on your own computer. And after I finish present that on the slide, I will also do it on my own computer. So it twice present. So if you cannot follow steps on the slides, and you can also follow my later practice on my own computer. Or even if you cannot follow these steps, you can watch our videos. First, double click this sample.gdf. The sample.gdf is on your data folder. Just double click this file. And then you will see 3 windows. First, in the import report window, just click OK without change any settings. And then close this welcome window. And these are the 2 steps. If you have installed GetFi and if you have the sample.gdf, then try to practice these 2 steps. Click OK and close this window, and you will see a graph like this. It might be a bit different on your computer to this graph because like social network analysis is a topology theory, and in topology theory, the position of the nodes or edges doesn't matter. But you can find you have 3 nodes can be connected with each other, and 2 nodes can be connected to each other. That would be fine. But this is the original data. We want the target, this one. How to visualize your data, or how to visualize this data? Let's see. First, change the colors of these nodes. First, go to the appearance and find the nodes, this nodes tab. You can follow the steps here. And then step 2, go to the color icon, and then go to the unique tab, and 4, right-click this color. You can try this, and then you will see choose a color window here. Although it looks a bit complicated, but we will practice a lot of operations like this. You will familiar with this very soon. And then in this choose a color window, just pick the color you like. You can pick any color you like. Just left click anything, any place here to find a color you like and click OK. And then click apply. Then you will give colors to these nodes. I will also do this on my own computer. Find appearance, then find the nodes, find this color icon, go to the unique, right-click this color, set to set color. Right-click this, you will find a choose a color, and then just click any color you like, and then click OK. And you have to click apply to color these nodes. Now you have the colors. Then let's go to the next step. Show the labels. How to show the labels? It's quite easy. First, here is the T signal here. Once you click this icon, you can show the labels for them. And then this bar, you can try it. This bar can change the size of the edges. And this bar can change the size of the this bar can change the size of the edges, can change the size of the links or the lines, and this bar can change the size of the labels. So, and you can try this on your own computer. Just click this black T icon. You will find you have the labels. Then you can change the size of the edges. You can also change the size of the labels, right? Okay, let's go to the next step. The basic operations on the graph window. Here are three very common operations on the graph window, which I will introduce. The first, how to move the whole canvas. It's quite straightforward. Just drag the canvas by your right button. Right-click this and then drag it, or you use your two buttons if you are a Mac user. Yep. And the next two, I will introduce them together. First, move one node is just drag the node by your left button. And the third operation is zoom in or zoom out. It scroll the wheels on Windows or slide two fingers up or down on Mac. Let's see this. You can scroll your windows or use your two fingers to scroll to go up or go down to zoom in or zoom out, and you can drag the canvas. And if you want to move one node, you can just left click this to move it. Okay, these are three very basic and very useful operations on this graph tab. Okay, let's go to the next. Next, we will introduce degree centrality, which both Professor Peter Ball and Professor Michael Fuller has introduced these techniques in their sections. Let's observe this graph. On this graph, we can find person B is so unique. Why he is so unique? Because B can connect to A and B can connect to C. So person B is the only person in this graph who can connect to more than one person, right? D, E, C, A, they can just directly to connect to one other person, but person B can be connected to two persons. So if we observe B like B knows A, also A knows B, we can say that person A knows person B, person C knows person B, and so person B can be known by two persons. If we go from this perspective, then we have a definition of famous. A famous person is a person can be known or to be known by more persons. So in this graph, we can define person B as a famous person. So because he can be known by more than one person. So the ability of this kind of famous attribution, we call it degree centrality. So B have more degree centrality here. So it's easy for us to know B is a famous person in this small graph. But it's not easy for us to know B is famous if B is in a graph which includes 1,000 nodes. So how to know who are the famous persons in this 1,000 persons? Then GetFi can help us. Let's practice this. Go to your appearance and find your nodes. And now we go to the size icon. Originally, or before we go to this color icon, now we are on the, we are using the size icon here. And then go to the ranking. And in this menu, we choose the only choice, which is degree. Then we set the min size as 50 and the max size as 100. Then click apply. You will find person B will be bigger than the other nodes, which means we use the size of the nodes to show the degree centrality. Just follow these steps. And if you have downloaded everything from the Google Drive, you must have these slides. Just go to this page 30 to follow the steps here. And I will also practice this on my own computer. Nodes, and go to this size icon and go to this ranking and find the degree from this menu and choose it. Then set the min size as 50 and max size as 100. Finally, click apply. You will find person B is a famous person. Now, let's try degree centrality on your own computer and on another set of data, which is a graph of 1,000 persons. The file name of this graph is Wuzhou and -songyuan.gdf. And you can follow the slides from page 22 or 23, from 23 to 31, but you will use the Wuzhou Songyuan data to visualize this data and to observe who are the important person or who are the famous persons in this graph. And the only different settings for this graph is that we set the min size as 10 and the max size is the same as this graph. Here we set min size as 10, max size as 100. Okay, let's try it on your own computer. I will also do this on my own computer. First, find the Wuzhou Songyuan from your data folder. Double click that. Then you will open this huge 1,000 nodes network. Well, so many nodes here. And then it's very hard for us to find who are the famous persons, or who are the top 1 famous, who are the top 2 famous, or we want to find the top 50 famous persons. It's hard for us to find them just by observe and drag and to guess. It's impossible. But GetFi can help us to calculate this degree centrality. First, we click this T to show the labels for them, and we can change the size of this label to make it a bit readable. And then we can do the degree centrality visualization for this graph. Go to the size, go to the ranking, choose an attribute, degree. We change the min size to 10 and max size to 100 and click apply. And now the label and the background are all black. So here we want to give it a different color for the nodes. So we go to the nodes and go to first click the nodes and find the color and right click the color here. And we can change the color to, let's randomly to. Okay, now you can find the labels for them. And here we can find the most famous persons in this network is this one, because he is very big. Even if you have any knowledge of this graph, even if it has 1,000 persons, Gephi will give you the ability to find the most famous persons in this big graph. 7055. This is a very famous person in this graph. And you can also find this also a very famous person, 3275. This might be a very famous person, and this might be a very famous person. Okay, now you finish the degree centrality and just in seconds. So this is the power of social network analysis. But if the data looks like this, it still needs our efforts to drag the big nodes from the crowd. Can Gephi automatically help us to visualize the layout, give us a pretty layout of these nodes? The answer is yes. How to do this? First, go to the left bottom of your Gephi window here, layout. Then you can find this layout tab here and do some settings here. First, drag this menu and choose the force atlas 2. And then select this dissuade hubs. And then select the prevent overlap. Select this too. And then just click run. It will give you a very beautiful or very clear layout of this graph. I will also do it on my own computer. You can also follow these steps. First, find the layout, choose a layout, find force atlas 2. And then click the dissuade hubs and also click the prevent overlap. And then click run. It will change the overlap. It will change the layout of these nodes. And if you find that the layout is good for you, please do click the stop, because this layout is from an algorithm. This algorithm costs your CPU a lot, so you must click stop to stop running this algorithm. Okay, if I think this graph is good for me, then I just click stop. Then we can find here are the most important persons. Okay, then if we want to know the names of these IDs, we can also use Gephi. We have already connected that information in the Wuzhou Songyuan data in this GDF data, and we can use Gephi to show them. For example, show their names. How to do it? First, find the attributes icon here. Just left-click this icon, the attribute icon, and then you find the label text settings. Then first unselect the label, then select this pin in, just select this pinyin and then click OK. You will find the labels. I will also do it on my own computer. First, find the attributes icon, left click it, and then unselect this label, and then select the pinyin, and then click OK. And now you will find who are the most famous persons in this network. This is Lu Zuqian, and this is Chen Liang, and this is the famous Zhu Xi. And in China, persons' name often begins from their family name and then their given name. So here, Lu Zuqian here means his family name is Lu and his given name is Zhuqian. So it's easy for us to find these famous persons in this graph. And if you want to know more detailed data about these nodes, we can go to the data laboratory to find the information of these IDs or of these nodes. So here you can find each lines represent to one person, or each line collected the information of one person. So 13886, his name is Pan Jinggui, and his birth year is 1130, and he is from Jinhua, or the coordination of Jinhua is here, and he is a male. So you can find the detailed information of your graph here in the data laboratory. And what is the data? The data is from Professor Peter Ball's keynote speech. This is one of his queries of the Jinhua of the Wuzhou data. And Wuzhou, as Professor Peter Ball mentioned, is a place on east side of China. He used the access of China biographical database to find or to query this data. I believe you heard a lot of time of queries in Professor Peter Ball's keynote speech. So how to do the queries? You can see that. You can see the interface of our query system. First, he define what the result of the query. Professor Peter Ball wants the individuals of these persons, and what is the address condition of these individuals is a Wuzhou. So this is the Chinese characters of Wuzhou. And then he defined the birth years of these persons. So it from 1120 to 1234. So in the access of China biographical database, you can easily to query the persons from some specific address and from some specific time. After you got this data, Professor Peter Ball do some historical research on the data to refine the data, to remove some persons, to add some persons, because our workshop is a workshop for the GetFi. So we will not practice these historical techniques or historical research, and we just practice in GetFi. And then after you find this kind of the person from Wuzhou and from a specific time, and you can use the China biographical database access to store these persons, and then find the social networks of these persons, and just run the query. You can find the 1,000 nodes in this network of this 900 Wuzhou data. So here you can find the social network of these of these Uzhou persons. And just click this save to get file. You can get the data, or you can get a file of the Uzhou Songyuan. This is also what I got this data from China, from the access of the China Biographical Database project. Okay. Here are more functions of CBDB or of the China Biographical Database. You can use the access version of the database to query person names or query by methods of entry into government, query office holding, query kingship, query social network, query pairwise associations, query place associations, and query status. If you are interested in these queries, you can read CBDB user manual here. And we also show the description of all the tables in the China Biographical Database and all the description of all the fields in each tables in this codebook file. So the codebook you can help you to understand more about Professor Michael Fuller's introduction of the club categories and the links between different kind of tables in the China Biographical Database. Then we introduced the components before at the beginning of this section. So how to find components in this 1000 node network? It's quite easy. Let me do this on the slides first. First, at the right side of your get file, you will find network overview. Then find the connected components. We introduced connected components at the beginning of this workshop section. And then click the run to run the algorithms for you to calculate the connected components in this graph. After you click the run, then you can see this window, connected components settings. Don't change anything, just click OK. After a while, you will see this report. It means the get file has finished the calculation. And it also gives you the algorithm of calculate the components here. If you are interested in this algorithm, you can read this article here. And here we just close this report, and to visualize the calculated data on the front end. So how to visualize it? You can follow the steps here. But first, I will calculate my connected components on my own computer. First, go to this connected components, left click run. You can follow the steps here and don't change anything, just click OK, connected components, and close the window. Here you can find 616, a number here, which means get file found 616 different components in this graph. And then visualize it on the front end. First, in the appearance, left click this nodes, find the color. We changed the color before. I think some of you might remember this. Find this color icon and go to the partition. And in this menu, choose the component ID. Before you click that run, you cannot see this component ID. After you click that run, this option can be shown on this menu, and then click apply to change the colors or to assign different colors to different components. And you can see here have the percentage, which means 44% of the nodes can be linked to one big component here, and other components are very small here. Yep, let's do this. First, appearance, nodes, color, and then we switch to partition, and then choose the component ID here, and then apply. Here you can find, here is a big node, a big component. And this big component, and after we get this big component, we can also find the communities within a big component. Because if we observe this big component, we can find that some nodes are close to some nodes, but some nodes and some nodes are very far. It must have some subgroups in this component, and GetFi can help us to do this. And first, in modularity, also we tried connected components before, and just above that option, we can find modularity, and just click this run, and then just like what we did before, click OK without change anything, and then click close, and then in node, color, partition, it's just like what we did in for the component ID, and choose the modularity class here and click apply. Okay, let's do this. Then different communities was colored by different colors. So it's easy for us to find the different communities in this graph. And this community ID, and here this purple color means the community ID is 275, and this is 1. And you can use you can find this ID. Also, you can also find this ID in data laboratory. You can use this data to do other statistic research. Then let's go to next. Let's rethink the network, the ability to bridge persons. First, we introduce this graph to you. Person B is a famous person, right? And if you change our perspective, person B is not only the famous person, but also is a person who can bridge other persons. Person C and person A and person C can be bridged by person B. If person B disappears, then person A and C cannot be connected indirectly. So this is the ability to bridge nodes or other communities is called betweenness centrality. Let's try a graph on GetFi first. You can find a file named chengyi and shushi.net in your data directory here. Just double click this graph to open this graph. And do the degree centrality to visualize the data. We did degree centrality twice before, so I believe you can do it on your own. And if you forgot some details, you can go to the page 23 and to follow the steps here. And I will not introduce that in the slides and just do it on my own computer, because this we have practiced it twice before. First, click OK to open this network and go to the Overview tab. And we can find these persons, these nodes, and these edges. We do first we show the labels for them, and then we do the degree centrality, go to the appearance, nodes, and size icon, and go to the ranking and choose the degree. And we set the mean size like 10, that will be fine. Max size is 100, that will be also fine. Click apply. Then we can find this graph. And in this graph, we can find two very unique persons, which was colored by black. I will introduce different colors later in several minutes. And it's easy to find the most famous persons in this graph. And how to do the betweenness centrality. First, go to the network overview, find the network diameter, this option just above this modularity, the network diameter. Just click the run, and also the same thing. Don't change anything, just click OK, then close this window. Then we got the data on the back end. We need to visualize it on the front end. Nodes, size, ranking is just the same as the degree centrality. And then choose the betweenness centrality instead of degree and apply. First, find the network diameter, click run, click OK, and then close this window. In this, we don't need to change anything because we just did the degree centrality. Then we find betweenness centrality here in this menu and just click apply. Okay, now let's compare these two graphs. In the first graph, degree centrality, we can find the famous persons, but it's very different on the second graph. The Xu Xi and Cheng Yi are smaller in the betweenness centrality, although they are famous persons. Why? They have the abilities to connect to other persons, but they don't have too much abilities in this graph to bridge persons. And in the betweenness centrality graph, we can find this Sima Guang and Fan Zhuyu and Wen Yanbo. They are very unique in this graph. So we can find the ability to bridge persons in this graph. So thank you so much. This is my email address. This is Professor Michael Fuller's email address. If you have any questions, please just contact us. So I will take it over to Professor Chen Song.
Thank you very much, Hongsu, and thank you very much, Michael, for giving us a wonderful introduction of CBDB and how the CBDB data might be queried and imported into GIFI and other programs for analysis. Now, I would just want to say, now we're at the end of the day today, so I would like to just say a few things about tomorrow and also about CBDB. Because many people ask the questions about the MBD data files that we can download that includes the CBDB data and the querying interfaces. That is a Microsoft Access data, so you can only use it on PC machines, or if you have a Mac machine, you have to run the virtual Windows operating system in order to use it. And of course, you also need to have Microsoft Access programs installed on your computer. Now, but CBDB is currently developing an online interface that will come out in the near future that will make the querying much easier. And we also have a SQL version, a SQLite version that you can also download from the official website of the China Biographical Database Project.